Hi everyone, today's lesson is a review of the homework packet for the midterm that you're going to be taking this week. So let's get started. The first question is about reconstructions, the first set of questions. So we're going to start with, it is not possible to construct an angle of 45 degrees. Actually, it is. If you're given a line segment and you were to take a compass, and your compass is going to measure this from here to here, you're going to arc up, you're going to arc down, you're going to switch it around, you're going to arc up, you're going to arc down, and then you're going to have this straight line that comes through here. And then that's perpendicular, that's a 90-degree angle. So then the next thing you would do is to construct a 90-degree angle or a 45-degree angle, you would make an arc like this with your compass. You'd put the sharp part right here. You'd arc out in the middle there. You put the other point here, you arc out here. And then what you've done is you've now bisected that angle, and therefore that 90-degree angle is now 45 degrees. So it's not possible, so it is possible. So this statement is false. Which of the following is possible to construct? A segment congruent to another segment. Of course, you can create a segment measuring that side, and then you would start here and you would measure this side with your compass, and you would create this other segment by measuring the same measurement there. So that's yes, that's a yes. The bisector of an angle, so we did that already. A line parallel to another line, of course, the first thing you would do is draw a line, and you would have a point not on that line. And the next thing you would do is you would draw a transversal, arc here, measure the arc, and then here, there's your line parallel. So yep, you can draw a line, you can construct a line parallel to another line. And an angle congruent to another angle, if you're given an angle, okay, and you have to construct an angle congruent to that, the next thing you would do is you would measure this arc here. Let's say I'm going to do it on this line here. You would create that same arc that you created here. That same arc would go over here. You would measure this arc here, measure the arc there, and then you would connect the measurement here. You would connect this with this, and therefore you would have a congruent angle. So that's also checked. So this would be all of the above. This question right here says, given x, y, what type of triangle would be constructed by making an arc from x and y with radius x, y? So what you're doing is you're basically measuring this distance here and arcing up. So you're measuring that distance, you're arcing up, you're turning it around, you're measuring the distance again on this side and arcing up. What ends up happening is you have the same length. This is the same length as this, which is the same length as this. So this all comes to be an equilateral triangle. And lastly on this page, to construct a median in triangle ABC. So let's say here's my triangle. Here's A, B, and C. To construct a median in any triangle, the first thing you need to do, well, let's figure this out. What we need to do is, let's say I want to construct median AD, okay? So in order to do that, to construct median AD, I would first need to bisect BC. And doing that, you're going to arc up, arc down. And what you're doing, and the reason why you're doing this, is so that you can find this midpoint. And the reason why you want to find that midpoint is to connect your vertex A with that point D. So the first thing that you would do for this is you would need to create a midpoint. And the reason you would want to create a midpoint again is to connect vertex A with the midpoint right here. So now I have median, because this is my median, and I would need to create median AD. Okay. The next question says, which of the following constructions are also based on perpendicular bisectors? Well, medians, of course, we just did that, where you would bisect a side, okay? And in bisecting this side, you're creating a perpendicular bisector. Medians would then connect to the midpoint right there. That's congruent to that. So that would be correct. Angle bisectors have nothing to do with perpendicular bisectors. Perpendicular bisectors, meaning they come down to be a perpendicular value. altitudes. So an altitude also would come down. So let's say I measured, let's go from this corner right here. If I were to measure from this corner out, remember what you would have to do is extend this line, because your altitude would then, your arc would then go like this, right? You would measure this length from here to here, and then you would actually bisect that by arcing from here, you'd arc that way, from here you'd arc this way, and then you would have your altitude, which is like this, which is also a perpendicular bisector of this arc right here. So an altitude. So 1 and 3, oh, that's this one right here, so letter E. The next question deals with trying to find the center of a circle. Now, these ones can be a little bit tricky. So what you have right here is the equation of a circle in general form. And what your objective is to figure out what the radius and the center is. And you do that by completing the square. And you notice that, see how you have an x squared and an x? You have to complete the square at least one time. You have a y squared, but no y. So therefore, I still only have to complete the square one time. So what I'm going to do is rearrange it, rewrite it. So I have x squared plus 2x. Now to complete the square, because you have part of it, you have to finish this to make this a perfect square. You take half of the b term. So you're going to take half of 2, which is 1, square that, and that's 1. And please remember that whatever, because this is an equation, whatever you do to one side, you do have to do to the other. So if I add 1 on this side, I am going to add 1 on this side. And I still have plus y squared, but I don't have a y to go with the y squared. So I still only have to complete the square one time with the x's. Now I'm going to factor, and this is going to be x plus 1 times x plus 1, which is the quantity x plus 1 squared, plus y squared is equal to 9. So what we have here is our center is at the opposite, because remember what the formula for the standard formula for a circle, and that's x minus h, quantity squared, plus y minus k, quantity squared, is equal to r squared. And that's given that hk is my center. That's what it's saying. So if hk is my center, notice that this value here says it's the opposite of h and the opposite of k. So when I write my center, okay, this is going to be -1 here, and it's going to be 0. Because this is actually, you could even rewrite that as y minus 0 quantity squared if you wanted to. Now, just for fun, I know it didn't ask you to write the radius, but on the test we will ask you to do that. That is equal to r squared. So if r squared is equal to 9, then r is equal to the square root of 9, which is 3. Sorry, square root of 9, which is 3. So just graphing this, we have -1, 0. I have a radius of 3, so over, left, down. So my graph would look something like this. The next question, this is not on your packet. I wanted to give you an extra question just because in this example, you're completing the square 2 times, because what you need to notice is, see how you have an x squared and an x? You have to complete the square one time. That's only part of it. You have to finish that to make it a perfect square, see? Which makes this, see, this is a perfect square. That's what you're going for. And see how I have a y squared and a y? I also need to complete the square there. So let's do that. We're going to go x squared minus 6x. Now let's complete the square. So half of 6 is 3. 3 squared is 9, so I'm going to add 9 here. I'm going to remember that, and I'm going to keep going. I have got plus y squared plus 12y. Half of 12 is 6. 6 squared is 36. So I'm going to add 36 to this side. I need to move this 4 to the other side, so it'll be equal to 4, positive 4, and then plus, remember how I added 9 and added 36? I have to do that. So add 9 and add 36. So on the left side, I'm going to factor now. This needs to be factored, and this needs to be factored. And just remember that when you're factoring these perfect squares, they're going to come and look like this. All right. So basically, the quantities are going to be exactly the same. All right. So a lot of people will go right to the next step. 36 and 4, what's that? 49. And so this is going to be square root of that x, square root of that 3. X minus 3 it's minus because see this negative sign? Negative times a negative is a positive, but when you add them up, negative 3x and negative 3x, that makes negative 6x. Now on this side, we're going to have y and 6. So y plus 6 and y plus 6. So what this ends up being is x minus 3 quantity squared plus y plus 6 quantity squared is equal to 49. And my center is at, remember, opposite, opposite. It's going to be at 3, negative 6. And because this value here is equal to r squared is equal to 49. So r is equal to 7. So let's graph this, okay? And in graphing this, it looks like our center is at over 3. Sorry about that. Over 3, so over 3 down 6, so around here. And then 7 to the left, down, right, all around. So there's my graph, okay? The next problem says if m is the midpoint at 3, negative 6. So we have over 3, down 6. So there's my midpoint, 3, negative 6. Of a segment xy, x is 1, negative 2. So here's x at 1, negative 2. What are the coordinates for y? Now, I always like to graph these because for me, I'm a little bit more visual. And if my line segment, they said, is xy, then this is x. Y has to be over on this side somewhere. And in order to find y, which we don't know what that value is, okay, we're just going to call it xy or x1, y1, whatever you want to call that. Remember, because if m is the midpoint, y has to be on the other side. And technically, this is a capital Y. So let me fix that for us. There we go. All right, so to find the midpoint, you're going to add up the x's, divide by 2. It's the average, right? So adding up my x's, I have 1. See this value here? 1 plus x. So 1 plus x divided by 2 is equal to the midpoint value. And then to find my y's, I'm going to add those up. So I have negative 2 plus y, so negative 2 plus y is equal to my midpoint y, which is negative 6. So negative 2 plus y divided by 2 is equal to my midpoint y, which is negative 6. So all I have to do here is cross multiply. And so we're going to go put this over 1. And I'm going to go 3 times 2. So I have 6 is equal to 1 plus x times 1. So x is equal to 5. And for y, I'm going to get negative 12 is equal to 1 times that, which is negative 2 add y. So here I'm going to add 2, and I'm going to get y is equal to negative 10. So my point is 5, negative 10. So 5, negative 10 is C. Just keep in mind that I also could have just counted, because a slope, you have the slope between x and m. You could have just gone down this many over, down, over, and ended up at 5, negative 10. So that's completely fine to do that. Just the reason why you would want to know how to do this, where you add your x's up, finding the average and set it equal to your midpoint, is because if the points were super large, then you wouldn't want to have to deal, with counting all the way over. Which is the length of the shorter base of a trapezoid if the longer base is 15 inches? So here's 15. That's my longer base right here. And the median, remember the median cuts this in half. So that equals that, and that equals that. They don't equal each other unless they're isosceles. And the median is 11 inches. So we don't know this value. Well, if you remember the formula from the median, find the median, it's the sum of the bases divided by 2. So if we said x plus 15 divided by 2, we would get the median. So again, in this case, I'm going to cross multiply. I'm going to go x plus 15 is equal to 11 times 2, which is 22. So x equals 22 minus 15, or 22 minus 15, which is 7. And that answer is D. Okay, so the next question says, what is the slope of the line that has this equation right here? Well, most people will find the slope of the line by subtracting or by solving for y or isolating the y. So I'm going to do that. So in doing that, the first thing I'm going to do when I rewrite this is move this positive 3x over to the other side of the equation. So I have negative 27y is equal to negative 3x plus 9. I'm going to divide everything by negative 27. So negative 27, divide by negative 27, and divide by negative 27. So this makes 1. So I have 1 times y, which is y. And this right here, negative divided by negative is positive. And 3 divided by 27 is 9. So that's going to be 1/9 x. And then 9 divided by into 27 is going to be 3. So that's minus 1/3. Now, the question was asking me, what's the slope? This is my y-intercept. They didn't ask me that, meaning that would be down 1/3. My slope is up 1/9. That graph looks something like that. So what they only asked me for was my slope. And make sure that when you're finding the slope, you don't attach the x to that. It's just 1/9. So this problem is B. Next question says, find the equation of the line that is the perpendicular bisector of segment AB. So I'm going to graph this. So over 1 up 3. So here's A at 1, 3. B is at -3, -4. So somewhere down here. So there's B at -3, -4. And so what they're looking for is a perpendicular bisector line. Okay, the equation of the line that is the perpendicular bisector. So that means that it's going to go through here like this. That's what they're looking for. They want that line and is also perpendicular. So 2 things that we need to think about. The first thing that we need to think about is, how am I going to get my slope? My slope has to be perpendicular. So that's one thing. The second thing I need to think about is, if for me to find the equation of the line that's the perpendicular bisector, I actually need the midpoint. So I need the midpoint and I need the slope. So let's work on that. So the first thing is, I'm going to look for the midpoint. So to find the midpoint is the sum of the x's divided by 2 and the sum of the y's divided by 2. So we're going to go parentheses 1 plus -3 divided by 2. And for my y-coordinate, I'm going to go 3 plus -4 divided by 2. So 1 plus 3 is -2 divided by 2, and that's -1. And this is -1/2. So my midpoint is -1/2, or -1 comma -1/2. So that kind of looks like it'd be right there. Okay, so that looks valid. The next thing I need to do after that is to find my slope. So to find the slope, what I'm going to do is I'm going to find the slope of AB. So in order to find the slope of line segment AB, I'm going to subtract my y's over subtract my x's. That's the same thing as saying the change in y over the change in x. Just be careful that you subtract your y's over subtracting your x's. So in doing this, let's see, subtract our y's. So we're going to go 3 minus this value, which is -4. And we're going to have 1 minus -3. So these negatives make positive. And so what I have is 7 over 4. 3 plus 1 is 4. So I have 7 over 4. Now, remember, the slope of the line that's parallel is the same. But the slope of the line that's perpendicular is the opposite reciprocal. So if this is positive, it's going to be negative. And if this is 7/4, it'll be 4/7. So what I have is now my midpoint, and I've got my slope. So what I need to do now is find the equation of the line. Now I'm going to use point slope form. So remember, point slope form looks like this. Y minus k equals m times the quantity x minus h. And this is given a point at hk, and m is my slope. So what we're going to do is we're going to use the values that we have. So we have our point right here that's going to go through here. See the point? This is going to be, it's got to go through that point. So we have a point and we have a slope, therefore point slope form. So we're going to go y plus 1/2 is equal to my slope, which is -4/7 times the quantity x plus 1. And that's it. Determine whether TUXY is a rectangle given the set of vertices. Justify your answer. So for number 11, let's see, I'm going to plot my points first. So we have -3, -2, so that's t, -3, -2. I think it's important to put the points next to the actual point values next to the point, and it helps you when you're trying to prove it. -4, 2, so we had -3, so now we have -4, 2, so this is u. X is 2, 4, so over 2, up 4, so here's x, 2, 4, and y is 3, 0, 3, 0. Okay, and so what they're asking me is if this is a rectangle. Well, it kind of looks like a rectangle, but to prove it, what you would do is you would either prove that one pair of opposite sides, both pair of opposite sides are congruent, and or you could prove the rectangles are congruent, the diagonals are congruent. I think what I'm going to do is I'm going to prove that the angles here are either perpendicular or they're not. So what we'll do is I'm going to find the slopes of these angles. So first I'm going to find the slope of ux. So the slope of ux is going to be, subtract my y's. So I'm going to go 4 minus 2 over 2 minus -4. And I'm going to get 2 over 6, which is 1 over 3. Okay? And for my slope of xy, let's see, let's find the slope of that. So that's going to be, subtract my y's, so it's going to be 0 minus 4 over 3 minus 2, and I get -4 over 1. Well, these are not opposite reciprocals. If these are not opposite reciprocals, then it's not a rectangle. So you would say, therefore, TUXY is not a rectangle because the slopes are not opposite reciprocals. And to prove that, you can also go 1/3 times -4 over 1, which is, if they were perpendicular, then this value here would be -1, which it's not. So therefore, that's not equal to -1. So therefore, it's not a rectangle, because a rectangle has to have 4 perpendicular angles, and this one does not. Determine whether a figure given their vertices is a parallelogram. So if I want to know if this is a parallelogram, the first thing I need to do is to use the distance and slope formula. So let's use that. So we have -2, 1, which is S. So that's -2, 1. R is 1, 3. T is 2, 0. And Z is -1, -2. Let's see. Okay, so in order to prove that this is a parallelogram, some things that you need to know about a parallelogram is that one pair of opposite sides are congruent and parallel. So let's try that. So we're going to try SR. So SR, the length of SR is equal to, using the distance formula, subtract your x's. So we're going to go -2 minus 1, quantity squared, that's a 1, plus subtract my y's, 1 minus 3, quantity squared. And for this value, I get -3, quantity squared is 9, plus, and then I have 1 minus 3, which is -2. -2 quantity squared is 4. 9 plus 4 is 13. So that's the square root of 13. So SR is the square root of 13. Okay? Let's find the value of ZT. So now we need to find ZT. So that's the square root of, subtract your x's. So -1 minus 2, quantity squared, plus -2 minus 0, quantity squared. So that's negative 3. Negative 3 quantity squared is negative 3 times negative 3, which is 9. Negative 2 minus 0 is negative 2. Quantity squared is 4. And so that's going to be square root of 13. So far, we have opposite sides congruent. Now, for this to actually be a parallelogram, we've already used the distance formula. Now we're going to use the slope formula to prove that the one pair of opposite sides is both congruent and parallel. So for them to be parallel, my slopes need to be the same. So now I'm going to find the slope of SR, and in doing that, we're going to go subtract my y's over subtract my x's. So I'm going to go 3 minus 1 over 1 minus negative 2. So I get 2 over 3. So the slope of SR is 2/3. So now I need to find the slope of ZT. So ZT slope, oops, hold on, so let me write that the right way. So the slope of ZT is equal to, now I'm going to subtract my, let's see, ZT, subtract my y's, so that's 0 minus negative 2 over 2 minus negative 1. And so that's going to be 2 over 3. So my slopes are the same. So that means if my slopes are the same, and if one pair of opposite sides are both congruent and parallel, it is a parallelogram. So therefore, these three little dots mean therefore, SRTZ is a parallelogram. Okay. Determine whether a figure with the given vertices is a parallelogram. So this is the second part of it, and they want you to use the midpoint formula. Well, it's a midpoint form. You're going to use the midpoint formula because the diagonals, if they bisect each other, right, which they're supposed to, they need to have the same midpoint. So if they have the same midpoint, then it's a parallelogram. So let's plot these. We have over 2 up 5. So W is 2, 5. R is, let's see, 3, 3. So we'll see it's about right there. Y is negative 2, negative 3. Negative 2, negative 3. And N is negative 3, 1. So this is N, negative 3, 1. So connecting these, are trying to figure out if this is a parallelogram. Okay, so and they want me to use the midpoint formula to check for my diagonals. So they want me to do this. Check to see if they both have the same midpoint, or if they both bisect each other by having the same midpoint. So we're going to find the midpoint of NR. Okay, in order to find the midpoint of NR, so here's NR here. We're going to add our x's up, divide by 2. So we're going to go negative 3 plus 3 divided by 2. And I'm going to add my y's up, and I get 1 plus 3 divided by 2. So negative 3 plus 3 is 0. 0 divided by 2 is 0. So far we have 0, comma 4 divided by 2, which is 2. So we have 0, 2. To find the midpoint of, let's see, that's NR. Now we're going to go for YW. And so the midpoint for YW, we're going to add our x's up, divide by 2. So we're going to go negative 2 plus 3 divided by 2. And then we're going to go negative, let's see here, negative 3 plus 5 divided by 2. So we have negative 2 plus 3 is 1. So we have 1/2. And negative 3 plus 5 is 8. 8 divided by 2 is 4. So, oh, that's not right. 1/2. Let's see here. Okay, sorry about that. Let's redo that one. Okay, do this again. I got my wrong points here. Okay, so I'm trying to find the slope, or the midpoint of YW. Okay, so in order to find the midpoint of YW, I'm going to add my x's up. So negative 2 plus 2 divided by 2. And I'm going to go negative 3, add 5 divided by 2. So that's 0 divided by 2. Oh, 0. And then negative 3 plus 5 is 2. 2 divided by 2 is 1. Uh-oh. So we have this midpoint is 0, 1. This midpoint is 0, 2. They don't have the same midpoint, so therefore WRYN is not a parallelogram, and the reason is because the diagonals don't bisect each other. If the diagonals bisected each other, they would have the same midpoint. Because the midpoints are not the same, it's not a parallelogram. Which of the following polygons is not necessarily similar? So for this problem right here, you're trying to find out, well, you know that two equilateral triangles are similar. You know that two squares are always similar. And regular, meaning those are always similar. So the polygons that are not necessarily similar are isosceles trapezoids. Okay, because I mean you could have an isosceles trapezoid that has the bases are not similar. They're not proportional. So which of the following proportions is not equivalent to this? So just looking at this, let's see here. We could flip this around. So you could do this a couple of different ways, but number one, you could say x is to 4 as 5 is to 9. So you could flip them like this. See that? You could, let's cross multiply. This is 9x is equal to 20. If I were to cross multiply that, I'd get 9x equals to 20. If we were to check this way, x plus 5 over 5 is equal to 4 plus 9, which is 13 over 9. Check. So far, all three of these work. Let's try this one. If I were to cross multiply, I got 5x equals not. Oh, and this is not the same, obviously. So these are not congruent, or those are not equivalent. So for this one right here, you want to solve for x and y. So a lot of people like to separate their trapezoids. So we have the small one, and then we have the large one. Okay, and that's completely fine to do that. You don't have to. You can. The small one is x, so we'll call that x. The large side here is 15. The small side here is 10. The long side is going to be 24. You know, this is right. This is little right. This side is 12. You know, the top here is 16. And do we have everything here? Oh, this is y. So your job is to solve for x and y. So to solve for x and y, so we're going to make a proportion. So we're going to go, and this right here, by the way, is 16. X is to 15. So we can go x is to 15 as 10 is to 24. Now, I could have found the scale factor first and then done that. Scale factor meaning side to side. So 10 is to 24 is my scale factor. And then let's say I divided that by 2. That would be equal to 5 over 12. And all that does right here is it just makes the numbers smaller that I have to work with. Okay, so it's completely optional. So cross multiply, I have 12x is equal to 5 times 15. I'm going to divide by 12, and I'm going to get 1 here. So x times 1 is x. 12 is actually 3 times 4. I'm going to divide this 3 into 15, and that's 5. So 5 times 5 is 25 over 4. So far, x is 25 over 4. So that actually knocks out both of those because only these two have x at 25 over 4. So now to find y, we're going to use the top here. Y is to 16. As scale factor again, 5 is to 12. Cross multiply, 12 times y is equal to 5 times 16. Divide by 12 on both sides. And I'm going to get y is equal to, let's see here, 12 breaks down into 4 times 3. 4 divides into 16 4 times. 5 times 4 is 20. So I get 20 over 3. So that would be B is my answer. The next question says, for number 16, it says, which of the following similarity postulates, theorems, would be used to prove the following triangles are similar? Well, for this one right here, this one's pretty simple because you have already this angle congruent to this angle, and then you have this angle congruent to this angle. So this is just, that was just pretty simple, which is angle, angle. You don't have any sides for this one, so you just use angle, angle. Solving for x for this problem, I like to go, personally, leg is to base as leg is to base. That's what I like to do. So we're going to do that. So we're going to go 9 is to this base, except for they didn't give me that value. But they gave me this little value is x, and this whole length is 10. So that means this length here is going to be 10 minus x. So we're going to go 9 is to 10 minus x as 6 is to x. I'm going to cross multiply. I get 9x is equal to 6 times 10 minus x. I'm trying to solve for x. So I notice that I have x's over here too. So I need to distribute that. So I have 9x is equal to 60 minus 6x. I'm going to add 6x to both sides. So I'm going to add 6x to this side and this side. Oops. And so here I'm going to get 15x is equal to 60. And I'm going to divide both sides by 15. So x is equal to 4. So my answer is 4. Okay. This one here says solve for y. Where's y? Here's y. Okay, so I need to solve for that. Now, there's a couple ways you can do this. A lot of people like to use base is to height as height is to base. They like that geometric mean there, meaning 3 is to z as z is to 7. Cross multiply, z squared equals 21. So z equals the square root of 21, and put that here. And then once I have that, I can use Pythagorean Theorem, and I can say a squared plus b squared is equal to c squared. Okay, so you can say square root of 21 squared plus 7 squared is equal to my y squared. I've got 21 plus 49 is equal to y squared. 21 and 49, what is that, 70? So 70 is equal to y squared. So y is equal to the square root of 70. Now, I mean, that's just one way to do it. Another way of solving this was to just use hypotenuse leg, where you can say, think of the big triangle, right? The big triangle, there's my hypotenuse. So you would go 10 is to leg, y, as hypotenuse, y is to leg, 7. And so doing that, you could have y squared equals 70, so y is equal to the square root of 70. So see how much quicker that was by doing that? You have that option of, your choice. 19, the scale factor is 5 to 2. So if VA is 2.5 and VB is 1.7, what's VN? So they want that. So, well, this piece of information here is not necessary. You didn't need that. They gave you extra information that you didn't need. So basically, you're just going 5 is to 2 as 2.5 is to x. And then you just cross multiply. 5x is equal to 2 times 2.5. And so you have x is equal to 2 times 2.5, which is 5, divided by 5. This is my divided by 5. And that equals 1. So my answer is 1. In the diagram below, segment RT is parallel. So this is parallel to this. It's parallel to segment SU. All right. You know that PT is 32. You know that PU, this whole length here, is 48. Well, that makes this 16, right? Okay. RS is 10, and your job is to find PR. Oh, well, you can just go x is to 10 as 32 is to 16. So, and actually that's 2. So you can go x is to 10 equals 2. X equals 20. So that's completely fine to do that. I also would encourage you to, sometimes it's in your best bet to separate the triangles. And you're welcome to do that, meaning this was what we're trying to find. This whole length would be x plus 10. This length here was 32, and the whole length was 48. So you would just go x is to x plus 10 as 32 is to 48 and cross multiply it, you're going to get exactly the same answer, x equals 20. It's just another option. So just keep in mind, you do have options when you're doing these proportions and definitely some of these problems. 21. It says, in a schedule of 6 classes, Mary has 2 elective classes. So she has 2 elective classes out of, what, 6? Okay, so out of 6 classes. So what is the ratio of elective to non-elective? So it's just 2 to 6, which is what, 1/3? Okay. An artist in Portland, Oregon, makes bronze sculptures of dogs like that. The ratio of the height of the sculpture, so they're looking at this height to the height of the dog, okay, is 2 to 3. So the height of the sculpture, if the height of the sculpture is 14, so you'd go 2 is to 3 as, because you're doing sculpture is to dog as sculpture is to dog. So the height of the sculpture is 14. What's the height of the dog? So you just cross multiply. You go 2x is equal to 3 times 14, divide by 2. So x equals 3 times 14, so 242. So that's going to be 21. All right. The next question says, find the measures of the sides of each triangle if the ratio is 3 to 5 to 7. So they're saying 3 of something, 5 of something, and 7 of something. Now, what you know is that the sum of the angles of a triangle add up to be 180. Now, in addition to that, what you also know is, what is this? It says, oh, this is the sides, not the angles. So let me fix that. Okay, this is 3 of something, still 3 of something, but not angles. These are sides. 5 of something and 7 of something. So really what we're doing here is we're trying to find the lengths of the sides. So I need some more information. See right here, this is the perimeter. If the perimeter is 450, then the ratio has to add up to be 450. So you have 3 of something plus 5 of something plus 7 of something is equal to 450. And so that's 15 x's is equal to 450. I'm going to divide by 15. I get x is equal to 30. So that means that this length of this side, so we've got 3 different sides, right? We have 1 is 3 times 30. So the length of side 1 is going to be 3 times 30, which is 90, okay? Then we have 5 times 30, which is 150 centimeters. And then we have 7 times 30, which is 210 centimeters, okay? Cool. Complete the triangle, complete the information below. We know that ABC is similar. Parallel lines have alternate interior angles that are congruent. So we actually know this angle is equal to this angle. We also know that this angle down here, this here, is equal to this angle here. D is equal to B. We also know that this angle is equal to this angle here because they're vertical angles. And vertical angles are congruent. So ABC is similar to ABC. You're going to say EDC. So this is EDC. You got to be very careful the way you say these. Then you know that AB is to ED, and you want to say it that way, as AC is to EC, as BC, where's BC? Here it is. BC is to DC. To find x, this is x, we're going to make a proportion. I'm going to say x is to 21 as 10 is to 15. That's my scale factor. 10 is to 15 is my scale factor. Divide by 5, I get 2/3. So my scale factor is 2 to 3. So I can say x is to 21 as 2 is to 3. So we get 3x is equal to 2 times 21. Divide by 3. 3's cancel. I get x equals 3 divides into 21, 7. 7 times 2 is 14. So x is 14. And I need to find y. So here's y again. So I can say 12 is to y as scale factor. 2 is to 3. Cross multiply. 2y is equal to 3 times 12. Y equals 3 times 12 divided by 2. So y is equal to 2 cancels into there 6. 6 times 3 is 18. Okay. Given the figure that HK, this is HK, is equal to HB, so I'm going to set those equal to each other. We know that also if sides are congruent, then their opposite angles are congruent. So that's Isosceles Triangle Theorem, Isosceles Triangle Theorem. HB is greater than KB. So if HB is X or A, or if it's greater than KB, if this is A, then this is going to be more than that. Now, what you're trying to prove is that AK, this length here, all right, is greater than KB. Now, I know you can't just say, oh, well, it looks like it. You have to actually prove it. And so to prove that it's bigger than KB, let's do that. So we know that this HK is equal to HB, and that's also HB is greater than KB. That's just given. Okay. Now you know that in triangle HBK, angle B has to equal angle HKB. B equals HKB angle, the measure of angle, KHB. Let me say it the right way. The measure of angle KHB. And this one is using the Krokodil Theorem. If you recall that. Okay. Okay. Always know that the sides opposite the largest angle have are larger sides than the other side. The exterior angle theorem basically says that if you have an angle, like for example, you have angle KHB is greater than this angle right here, this one. This angle is greater than angle A. And the reason why, and that is greater than the measure of angle A, is because remember the sum of the exterior angle is equal to the sum of the two. One exterior angle is equal to the sum of the two interior, remote interior angles. So if this plus this is equal to that, then just one of these, this has to be greater than that. You also know that the measure of angle B has to be greater than the measure of angle A, meaning this angle here has to be greater than angle A because it's transitive property. You've got, if KHB is greater than angle A, angle B must be greater than angle A because angle B is greater than KHB, which is the angle right here. So that's just a transitive property. Lastly, you have AK is greater than KB, the Krokodil Theorem. And again, and where for this one, you're using triangle KAB. The other one, when we were using the Krokodil Theorem up here, we were using triangle KHB. So and I really think it's important just to remember that if you have whatever sides that you have, the sides that are opposite, like this is the biggest side, that means this is the angle is the largest. If this side's the next biggest angle, that's the next largest. And if this is the smallest side, that makes this angle the very smallest too. So just remember that. Which of the following numbers could be the sides of an acute triangle? Again, the way I work these out is just to make sure that they all first are triangles. So, and to prove that, you would just add sum of two sides has to be greater than the third side. So 3 plus 4, yes. 1 plus 3, not greater than 5. So this one already is not a triangle. Okay, and so far we have all triangles. Now, what you need to remember here is that the longest side squared is equal to the sum of the other two sides. That's a right triangle. Sum of the other two sides squared. That's a right triangle. If you have this largest side greater than the sum of the other two sides squared, that's an obtuse triangle. And if you have the largest side squared and it's less than the sum of the other two sides squared, then it's an acute triangle. And that's what they're looking for, is which one of these is an acute triangle. So let's work this out. So it's largest side, largest side, largest side. So we've got 25 is what to 3 squared plus 3 squared. So that's 9 plus 9, 18. This is greater than. So this one's obtuse. Okay, that didn't work. This is a 3, 4, 5 triangle, so you know that's right. So let's see the largest side. So 7 squared is what to 4 squared plus 6 squared. So we have 49 is what to 16 plus 36, 3, 4, 5. So it's less than. So therefore, this is my acute triangle. This one is asking for the geometric mean between two numbers. And I always encourage people to draw diagrams. This is one way to show the geometric mean. And remember, we would go base is to height, as height is to base. I think this is, or leg is to height, leg is to leg, leg is to leg, whatever. However you learned it, they want to know that they're telling you that the geometric mean is 3 root 6. So there's your 3 root 6. They're telling you one of the numbers is 6. We don't know the other number. Find the other number. So you're just going to go base. So 6 is to 3 root 6 as 3 root 6 is to x. We're going to cross multiply. We're going to get 6 times x equals 3 root 6 times 3 root 6. I'm going to come down here so I have more room. X is equal to 3 root 6 times 3 root 6 divided by 6. And so what I'm going to do now is on the numerator, I'm going to multiply 3 times 3, which is 9, and root 6 times root 6, which is 6, and you're dividing by 6, so x is equal to 9 because these two values are going to cancel out. So D is my answer. The next question says, one acute angle of a right triangle has a measure of x degrees. So we'll call that, I don't know. If sine of that value is equal to 12 over 13. Now remember, sine is opposite over hypotenuse. So if I'm here, sine of x, and that's 12 over 13, hopefully you notice this is a 5, 12, 13. What's the value of x? Or tangent of x. So tangent of x is equal to opposite over adjacent. So that's just 12 over 5. So that's A. The longer leg of a 30, 60, 90. So okay, we'll call this 30. We'll call this 60, and that 90. Has length 9. So the longest leg is opposite the biggest side, not the hypotenuse, the leg. So this is 9. So your job is to find the length of the hypotenuse. So they want this value right here. So if you recall, when we were learning the 30, 60, 90 right triangles, special right triangles, across from the 30, we call that A. Across from the 60, we had A root 3. And across from the 90 was 2A. So what I really need to do is I need to find what's across from the 30, because that's my A. Across from the 60 is A root 3. So what I'm going to do is I'm going to solve for A. So I'm going to divide by root 3 on both sides. There's a shortcut, right? A is equal to, and I'm going to divide by root 3. So now I have 9 root 3, 9 over root 3. But what I need to do is to not leave a root on the denominator. So I'm going to multiply by 1 in the form of root 3 over root 3. So I have 9 root 3 over root 3 times root 3, which is 3. And 3 divides into 9 3 times. So A is equal to 3 root 3. Now, what do they want to know? The hypotenuse. So if this is 3 root 3, A, or across from the hypotenuse, is twice that. So that's going to be 2 times 3 root 3. So that's going to be 6 root 3. So there's my answer. Solve for x and y. Okay. Across from the 30 is A. Across from the 90 is 2A. This is my 60. This looks like a 45, 45, 90. Love those. 15, that's 15, right? X root 2. So that's 15 root 2. So if across from the 60, now we just did this, remember, that's a root 3. So what I need to do is I'll work that out over here. So I have 15 root 2 equals a root 3. I'm going to divide both sides by root 3. And these are going to cancel and give me a. So I have a is equal to that. So I cannot leave a root on the denominator. Okay, don't do that. You'll get it wrong. You're going to multiply by root 3 over root 3. So you're going to get 15 times root 6, because root 2 times root 2 is root 6. Root 3 times root 3 is root 9, which is 3. So this is over 3. And so that a is actually 5 root 6. So a, which is across from my 30, is 5 root 6. And across from my 90 is twice that. And so that'll be 10 root 6. Solve for x, y, and z. Okay, so for this one, oh boy. What should we do first? I think we need to do something with just x's in it. So meaning, if I did this and I went x is to y as y is to x plus 1, now I have x's and y's. I don't want that. So that's not helpful. So what I need is to do something like my hypotenuse is to leg as hypotenuse is to leg. So we're going to go small triangle, hypotenuse is to leg. So I'm going to go x plus 2 is to x as large triangle, hypotenuse, so that's x plus 1. So that's 2x plus 1 is to leg, same leg, x plus 2. And I'm going to cross multiply. I'm going to get x times 2x plus 1 is equal to that. So it's going to be x plus 2 times x plus 2. So that's going to be 2x squared plus x equals x squared plus 2x, which makes plus 4x plus 4. I notice that this is a quadratic, so I do need to set everything equal to 0. And so in doing that, I'm going to move that over. I get x squared, so these are gone. I'm going to subtract 4x, so I have now minus 3x. And I'm going to move my 4 over, and it says minus 4. So I'm going to factor. And doing that, I get x times x. Minus 4 plus 1 makes negative 3. Split this up. X plus 1 equals 0. So x equals negative 1. No, we can't have a negative length. X minus 4 equals 0. So x equals 4. So I know now that x is 4. So this is 4. 4 plus 1, that's 5. 4 plus 2, 6. So now we can find everything we need to do. So to find y, I'm going to go 4 is to y. So 4 is to y as y is to 5. So I have y squared equals this, or 20. I have 20. And then y is equal to the square root of 20. Square root of 20 is square root of 4 times square root of 5. So y is equal to 2 root 5. Okay, so we have y. We have x, which is equal to 4. And now we just need z. This was the square root of 20. I'm going to use Pythagorean Theorem for that. And in doing that, I'm going to go the square root of 20, quantity squared, plus 5 squared is equal to z squared. So I have 20 plus 25, which is 45. So the square root of 45 is equal to z. That's going to be 9 times 5 is equal to z. And root 9 times 5. So that's going to be z is equal to 3 root 5. Cool. Okay. All right. Next problem. Solve for x. Oh, boy. Now this one, you don't have a calculator. Oh, all right. So you don't have the hypotenuse. Opposite over adjacent. So you're going to go tangent of 44 is equal to opposite over adjacent. So without a calculator, you're just going to go this far. X equals 10.4 times tangent of 44 degrees. You're done. We don't know without a calculator what the answer is. I know the answer is D, but without a calculator, you really don't know that. So this is the answer that I would expect that you would write and be done. The next question says solve for y. So they only want this value right here. Do you want to do hypotenuse? I feel like I've done this problem. Oh, well, anyway, hypotenuse is to leg. So we're going to go y is to 7 as hypotenuse, big hypotenuse, 10 is to leg y. So I have y squared equals 70 square root of y. Yeah, I did do this one. So y is equal to the square root of 70. Check. Next one. Solve for b. B is here. We don't know the types of angles, so it's not a special right triangle. So for this problem, I'm going to say that we're going to use Pythagorean Theorem. So we're going to go 4 squared plus side squared is equal to hypotenuse squared. All right. And so that's 16 plus b squared equals 3 root 7 times 3 root 7. So 3 times 3 is 9. This is 7. 9 times 7 is 63. So we have 16 plus b squared is equal to 63. So b squared is equal to 63 minus 16. What is that going to be? 5. That's going to be what? 47. And so b squared is equal to 47. So b is equal to the square root of 47. That's that number. The longer leg in a 30, 60, 90 right triangle is 4. So I'll assume that's 30 and that's 60. The longer leg, which is this leg here, is 4. What's the length of the hypotenuse? So opposite the 60 degrees is a root 3. So we're going to go a is equal to 4 divided by, a equals 4 divided by root 3. Don't leave a root on the denominator. So I'm going to multiply by root 3 over root 3. So a is equal to 4 root 3 over 3. So that's a, which is right here. And so this value across from the 90 is twice that. So 2 times 4 root 3 over 3 makes 8 root 3 over 3. So this is your answer right there. Solve for x. You're trying to solve for x, and assuming that because all of my answers are at 39 degrees, I'm going to be here, right here. Okay, so what I have is the opposite side, and I have the hypotenuse. So that is going to be sine. So we're going to say sine of 39 is equal to opposite over hypotenuse. Now, you're not going to leave your answer there because calculator ready basically means you're solving for x. So I'm going to put a 1 under that, and I'm going to cross multiply. I get x times sine of 39 degrees is equal to 5. I get x equals 5 divided by sine of 39 degrees. So that's what my answer is going to be. So 5 divided by sine of 39 is right there. So this one is a plane is 8 miles horizontal distance. Oh boy, so that's telling me my horizontal distance. This is the horizontal distance. Away from the airport is 8 miles. So, okay, this could be tricky. Okay, all right. So that's 8 miles. Okay, when it began its descent. So here's my descent. Okay, and there's my right angle. If the plane descended at an angle of depression of 20 degrees, so keep in mind when the airplane starts descending, it's going down that way. That's 20 degrees. That angle, not that angle. That angle is the same angle as this angle right here. Okay, hold on. So what we're going to do is these two angles are equal because they're alternate interior angles, because my horizontal, anytime a plane starts descending, it always descends on a horizontal. So those are congruent. So the question is, what was the plane's altitude when it began its descent? So they want that value. So you don't have the length of the hypotenuse. You do need the opposite side. You have the adjacent side. So this is the opposite. This is my adjacent. So you're going to say tangent. Remember your SOHCAHTOA? SOHCAHTOA, okay? Where tangent uses opposite and adjacent. But remember that when you write this, tangent, the angle is always here. So tangent of the angle is equal to opposite over adjacent. And again, this is not going to show up here because what you need to do is make it calculator ready. So you're going to cross multiply. So x times 1 is x is equal to, so you have x equal to 8 times tangent of 20. And so that value is my answer. Where is that going to be? 37, 8 times tangent of 20. Okay. Okay. Next question. From the top of a 540-foot observation tower, there's my 540-foot tower, a park ranger sights 2 forest fires on opposite sides of the tower. So you've got park ranger Yogi here is sighting that one. And this is all, remember, it's based on a horizontal, right? And then you've got park ranger noticing that side there. And so when they're looking at the first one, so you've got never eat, here's 16 degrees, that you're going out that way, that's 16. And then the second fire is due west, so that's west. Angle of depression is 32, so that's there. That's your angle of depression. It says diagram, determine the distance between the 2 fires. So we want this distance right here. So basically this distance plus this distance. So what I'm seeing is that we have 540 here. You have an angle of depression 16. The angle of depression here. So this is 16, that's 16. If this is 32, this is 32. So basically, without a calculator, you're going to go opposite over adjacent. So opposite, because these are right. So you're going to go tangent of 32 degrees is equal to opposite over adjacent. And you're going to go tangent of 16 degrees is equal to opposite over adjacent. And so let's work these both out. So we have x times tangent of 32 is equal to 540. So x equals 540 divided by quantity tangent of 32. This one is going to be y times tangent of 16 is equal to 540. So y is equal to 540 divided by tangent of 16 degrees. So what you're going to do here, so 540 divided by tangent, you're going to use a calculator, which I don't have, but I do have the answer. So let me write that down. 864.181. So that's this value when you divide. And then this value on the other side here, tangent of 16. Okay, so y is going to equal 1883.204. And because what I'm looking for is the distance between the two, we're going to add the two values up. So it's going to be x plus y. So we're going to have 864 plus 1883. So the total distance is going to equal 29282 something. All right. And so that's that answer. Cool. What is the measure of the angle formed by the sun's rays with the ground when a 68-foot tree, 68. So 68-foot tree. So there's your 68. I don't think you can see that. Let's see here. 68-foot tree casts a shadow 14 feet. Remember, you guys, shadows are always on the ground. And so we want the angle. What are we looking for? What is the measure of the angle formed from there? So we're going to use tangent of theta is equal to opposite over adjacent. I'm trying to solve for theta, this angle right here. So we want to get that by itself. So theta is now going to move this over arctangent of 68 over 14. So theta is approximately 78.4. You do need a calculator for this problem. Okay. If sine of C, so here's C, is equal to that value, what is the measure of angle C? Well, the measure of angle C, okay, the measure of angle C is equal to arc sine of 0.8090. Meaning, see right here, you got to get sine by itself. So you're going to move sine to the other side. By the act of moving sine over to the other side makes it arc sine. So you would do this right here on your calculator, and then you just have the measure of angle C is equal to about, I think it's 54 degrees. Okay. And I know some of you we've gone over this with the graph. So just to reiterate that, remember a sine wave does this. Okay, so if a sine wave does this, and you know that the top angle is 1, the top value is 1, and this is -1, right? And this is the unraveling of the unit circle. This was 360. This was 180. There's 90. And so at 0.8, if this is 90, and 90 is at 1, if 0.8 is about right here, that's what they're looking for. What do you think that value is? Right around here. So that's what it is. And that angle is right there, because that angle is about 0.8. That's about 0.50. That's about 54 degrees. So that's what that is. That's where it says where is. Arc sine is like where is the angle. Okay. So anyway, that concludes the packet. And good luck. You got this. And good luck on your midterm. All right. Thanks for watching.